Hey everyone, we'll start in about 2 more minutes. All right. Hey everyone, thanks for tuning in. Today we're joined by Martin and Mihail from GetYourGuide and Greg from Arise. We'll be discussing one of their key AI systems, which powers millions of real-time rankings and recommendations for lots of people who are looking to travel. So, how about we start with some quick intros? So, Martin, how about you go first?
Hi, yep, I'm Martin. I'm a senior MLOps engineer here at GetYourGuide. I work within the growth data products team. So we're involved in bringing new customers in, making sure the company's growing this way, and also the other end too, making sure that we retain customers and customers are happy and satisfied. Things we can touch is like looking at Google adverts and stuff like this, trying to improve these things, and also things like some recommendation engines like cross-sell that suggest things that you might also be interested in.
Great. And then Mihail?
Yes, hi everyone. I'm Mihail Dohaniaris. I'm a senior data scientist in the activity ranking team at GetYourGuide. So my team and I work on improving the search relevance on our platform. So for anyone who's not familiar with us, GetYourGuide is an online travel platform where travelers from all over the world can book activities at their destination. And the ranking of activities is an important part of that journey of helping our users discover the activities that are the most relevant to them. So to optimize the search relevance, we of course use machine learning. So as visitors browse our platform, they generate a lot of data like page views, clicks, and bookings, which we then use as implicit feedback to train new and better ranking models. So this machine learning framework is known as learning to rank, and it's at the very core of what my team does. So yeah, it's a very key part of discovery throughout GetYourGuide's search features. So it influences everything from the homepage whenever the user first lands on GetYourGuide to specific destination pages as they're kind of finalizing their bookings. So critical driver of business impact. And yeah, our system makes 30 million ranking inferences on a daily basis.
Great. And then Greg?
Yeah, I'm Greg Chase from Rise. So I'm an ML solutions engineer, and I work with GetYourGuide. And what my team does is we act as the voice of the customer. So we help onboard customers, we help get them to value, introduce them to where they can get the most value out of our platform, and also help with troubleshooting questions they have.
Great. Yeah, thanks everyone. My quick intro for me. My name is Mihir. I'm one of the product managers at Tecton. I work with three teams. The real-time compute team, which is responsible for the computation of streaming features as well as any real-time features. I work with the real-time serving team, which is responsible for providing infrastructure for low latency, high throughput serving. And I work with the embeddings team, which is responsible for the ingestion, transformation, and serving of unstructured data into embeddings. So we got a sense of the scale from you, Mihail, that it's 30 million predictions per day. And Martin, you also talked about the platform. So building an AI platform that works at that scale and can deliver such large impact is fairly challenging. Could you describe some of the major challenges that you all face in just building such a high-scale AI platform?
Yeah, go on. I can take this one. So there are probably 3 stages of problems that we had. Coming from a team that had mostly non-live inference models, a lot of our things went live. So we came from very basics to what we have now, which is live models being served with live features coming through and observability as well. So the first one we had to solve was getting the whole pipeline for the live inference to work. These were things such as build, train, deploy, and getting our production models ready for consumers. A lot of our consumers are internal consumers. And I think this is a stage where the majority of medium-sized companies already are. I think a lot of people are already here. And this took us a while to get there, but once we got there, we had a good grounding then. But I think that was the important stage to get to. And then once we had this, the next thing we needed was real-time features. This is because a lot of the features we had were generated daily or in some cases weekly. And so we generally had stale features. So the next part was looking for a feature store of some sort. And there was many on the market, and we spent a lot of time looking around. And given the size of our teams, it kind of made more sense to have this managed by an external company. Otherwise, we need an entire team just for managing the feature store itself. So I think one of the biggest things there was coming on board with this, but also putting a system in place so everybody can quickly and easily use these features. Even though Tecton manages a lot of things for us, there's still a lot of things that are on our side that we have to do, such as the building and the generation of the features and bringing these live. I think once this stage was done, the next problem was monitoring our models. For a long time, we just had metrics that we sent to Datadog. And while these are okay and these are good, they're not really in depth in telling us exactly the state of our model and the data going into our model. And I think this stage here was moving away from Datadog towards Arise. And then what that gave us as well was not just our own overview of the model, overview of our feature health. It gave us also explanations of how the model's working as well. It was quite powerful. I think these 3 things together were the main problems that we had to solve, we had to overcome. And of course, while all this was going on as well, the company was growing and scaling, so we had to also manage the number of requests coming through and all this. And we can talk later if you want about how we scale and manage this.
Yeah, that makes sense. Greg, how would you say the problem that Martin just described about monitoring, how does that relate with the specific problems that customers come to you to Arise to solve? Like, what are some of the major problems?
It's the problem that Martin's talking about is relevant to all of our customers in some way. The common denominator that our customers come to us about, regardless of company, regardless of industry, is they need some form of observability on what they're building. And what that leads to is being able to say, hey, we want to perform root cause analysis on why something isn't performing well. We want to be able to go and surface what those insights are and be able to resolve them really quickly. So on the ML side of things, that can lead to things our customers contact us about, like how do we look at bad performance slices or subsets of the data? Can we look at when drift starts to occur in production versus when training the model? And then looking at things like fairness and bias. And then for our customers doing large language model work, the same aspect applies in a different way, which is, can we look at when retrieval is not working correctly? Can we look at prompt management? How do we troubleshoot a really opaque agentic flow? And then looking at how do we evaluate the output of an LLM with something like LLMs as a judge.
Got it. Yeah, that makes sense. And I might have follow-up questions on that. You mentioned a lot of interesting words that we can go deep in. Also, I would encourage any audience members to drop questions in the chat, I can also keep asking the panelists those questions. Um, but yeah, speaking of these like complex topics, one of the features that I heard Get Your Guide was building was a discounted ranking impressions feature, which also sounded like fairly complex to me, and it was like a real time feature, pretty impactful. So yeah, Mihail, since you're on the data science side, could you just give us a an explanation of what that feature is and how you use it and how you built it?
Yeah, sure. Absolutely. So maybe to give a bit of context. So more recently, we've been focusing a lot on like user personalization within our platform. So this also includes the ranking that our users see whenever they're browsing, for things to do. So one of the things that we've noticed is that users often visit our platform multiple times throughout the course of maybe a few days or sometimes even within the same day as they're kind of finalizing their booking. So they're browsing different activities, clicking things, reading things, comparing stuff. So that kind of thing. And this gives us a very good chance to kind of use these user-generated signals to then optimize our rankings in real time. So in response to all these user actions. So the discounted ranking impressions that you mentioned, this is a feature that's kind of a part of this effort. And the idea behind it is actually rather simple. So the feature essentially just keeps an up-to-date count of each visitor's impressions for a specific activity. And it also factors the position of the activity on the page where the impression has occurred. So that's kind of the discounting part. So then we can have this information in real time and then feed it to our ranking model and then optimize the display of activities that way. So maybe to give an example to kind of drive the idea home is, let's say a visitor has already seen a specific activity at a high position on our page a few times already, but hasn't like interacted with it, hasn't clicked on it. It might be best to just move that activity a bit further down to then make space for other potentially interesting activities. So I think a classic example of this is like YouTube. If you're familiar with YouTube, you might have noticed that each time you go on their homepage, you see a different set of recommended videos. So in principle, this is a very similar idea to our discounted impressions feature. And yeah, as you mentioned, we do this in real time. So we essentially consume our Kafka event streams within Tekton using a streaming feature view. And then it's readily available for our ML model to then query and use. And yeah, I would say maybe one more thing that like the really cool thing about this setup, like using Tekton, in my opinion, is that whether we actually need to access the latest, most up-to-date feature in real time at inference time, or just access the point-in-time correct historical values when generating data sets, there's just one single definition for the feature in Tekton. So this logic is kind of completely abstracted away from us. So that's really nice because it allows me as the data scientist to spend more time on feature and model development and worry less about, backfilling and avoiding data leakage. So yeah, I really like that.
Great. So yeah, Martin, Mihail mentioned a bunch of different things like backfilling, real-time things. Um, could you like give a system overview of like how all of these things are connected and how where Tecton and Arise fit in?
Yeah, sure. I think you have a diagram.
Yeah, I can pull up the diagram that we have. 1 second. Cool.
Awesome. Yeah, I see. Yeah, so the core of it is this very center part here. So the data scientist, our training pipeline, the ranking inference server. This is what we had in place first. And then tying into what Mihail's saying, so our pulling in of the historical features and retrieving live features through Tekton. They basically go through more or less the exact same interface, and we get access to these features directly. The nice thing for us with Tekton is that the backfilling happens automatically. So the moment that we create a feature, we push it to Tekton, and once it applies, it begins backfilling as far as we need, which is really useful for our training pipeline. This helps us a lot. Previously in the past, we would have to make our own queries, and problems here can happen. I think with Tecton, the one thing this brought about was a more consistent way of generating our training data. And it's nice that it all happens like automatically through the same definition of the features that we will be using in production anyway. Yeah, I think this part kind of works quite nicely. And then how we tie into Arise. Arise actually gives us multiple ways to send data to them. We can send them directly live via an API call. We can dump the data into S3 and things like this. But the way that we choose to do it is that we, during inference, we just send off a Kafka event. And this is what you can see here on the diagram. And once this goes through, our Kafka events are all stored and saved in a data warehouse for us. And then once a day, we can just call these. We get a data frame of the predictions we have for the day. And then we send these off to Arise. And these all come through. The nice thing for this for us as well is that the data scientist gets to see relatively quickly what's happening with the model, how it's performing, but also how is the data changing over time. I think this is the part that we never really had before, was how the data is changing. We always had metrics on how our model is performing, how well the model is, but this part of the the data changing, the features, this was like a really, really important part to us.
Great, yeah, thanks for that overview. Greg, is there anything, so this diagram shows like a Arise daily batch job being sent. Is there anything on the real-time side, real-time monitoring that Arise has that this diagram probably doesn't show?
So one of the items I can talk about is our monitoring system with that, because we do have a series of monitors that can be configured. So there's performance, there's data quality, and then there's drift, and they each do a few different things. But to something that Martin mentioned is that once data gets ingested, the customer, in this case GetYourGuide, can set up the monitors, and then when a threshold is, say, exceeded or above or below what was set, then an alert is sent out to people in question. It's normally the stakeholders or Slack channel, and then that gives them the ability to go and receive a notification that something's wrong, and then be able to then go to the monitor and then start looking at the troubleshooting process to perform root cause analysis.
Got it. So it can trigger in fairly like near real time, is what you're saying?
Yeah, like close
Okay.
to.
Close real time. Okay, cool. And I'll take a question from the audience actually. Approximately how many, so this is a question from Adrius. Approximately how many candidates you use in ranking, and or how many rows do you retrieve when you use Tectons? It's probably for Mikhail, I would say.
Mm-hmm. So by candidates, I assume we're talking about like the activities in our case. I think so. There's basically, it changes depending on the page size. So you can imagine, if you're looking for activities in Paris, then the pool of activity is much larger than, let's say, my hometown Helsinki, which is a much smaller city. So there is some differences there. And generally, we also have a 2-layer system where we do an initial ranking that's actually just a batch job, and then only a smaller subset of those candidate activities are then ranked in real time. So it depends a bit, and we do it in kind of two layers, I would say.
Got it. So there's like a lot of geographic variability in your just number of candidates.
Yeah, definitely.
Yeah. So speaking of variability, I think another place where there's a lot of variability is just the seasonal variability, because you might have different activities in the summer versus winter and just different number of things. But there's also the traffic patterns that change. So Martin, question for you. How do you handle this seasonal variability in traffic while ensuring just best performance and just that these systems continue to work as you have different seasonal patterns as well as peak events?
Cool. Yeah. So we have a few different ways of handling this. So the main backbone of this is horizontal scaling. We have horizontal scaling on the models and also the services that are calling these models and going through. These generally work quite well, and we're lucky at GetYourGuide in that a lot of our seasonal patterns are known beforehand. This is because people travel generally at the same times of year, and our patterns will pick up. So for this, we can also add a little bit extra on top of our auto scaling. So this way we're kind of generally okay. And then when we moved over to Tecton, We realized at some point as we're auto-scaling, and these are growing bigger, we're having more requests. Tecton itself was also then our bottleneck. And then quite recently, you released a thing so we can auto-scale our read node servers as well. And I think once this happened, then we saw things going really, really well. It's mentioned in the blog too that not only this helped us handle higher traffic, it helped us keep lower when we didn't need that many nodes, and overall, it saved us money in the long run. Yeah, so a lot of our things is more horizontal scaling with our traffic as we go through, with some business knowledge of when we're going to be scaling quite a lot.
Makes sense. Another question from the audience. How do you guys handle this from Rahul Girish Kumar? How do you guys handle cold start scenario for a newly listed activity? That's the first part. And the second is non-personalized ranking. So how do you handle non-personalized rankings for a user who hasn't logged in and is not identified?
Sure, I can take that. So
Yeah.
for the first part, the cold start scenario, that's a good question. That's definitely something we're constantly onboarding new activities to our platform, and we actually handle this completely outside of the ranking system. So for any new activity, for a brief period of time, we actually display that activity in a specific position on our landing pages. So this is to kind of collect some data on that activity that then we can utilize later on in our kind of main ranking system. And for the second part, I mean, we just have basically a default ranking, so our model can also handle cases where there's no features or we don't have any personalization features, for example, for that user. But then this doesn't require the user to necessarily even be logged in. So depending on on the settings that they've chosen, we can use that information of the event. Actually, let's say you click on something, of course we can access that information, so then we can use that as well.
Cool. All right, I'm seeing a few questions on performance. So let's actually shift gears a bit into model performance. So silent model performance degradation is every MLM engineer's nightmare. These systems can be a little bit black boxy, and if your inputs are changing, the performance can just change and not be fully deterministic. So tell us about a time when you uncovered a particularly tricky model performance issue, and if you could just walk us through how you diagnosed and fixed that, that would be great, Mihail.
Yeah, sure. So I would say maybe one thing to point out, like when it comes to performance degradation, or rather I should say any kind of data drift in general, I think it's important to kind of note that not all data drift is always bad or unexpected. So for example, as Martin just mentioned, our traffic varies a lot depending on like the travel season. So naturally, that also means that some of our features, like let's say the number of clicks or bookings that a particular tour receives, that will also shift. So that's kind of expected data drift. And another case where we always expect some data drift is in our model scores. Whenever that is the prediction scores for our ranking model, whenever we're launching a new, let's say, A/B test. So in this case, we're deploying a different variation of the model that maybe uses some different features. So naturally, you would expect some differences in like how these models predict, right? So that's also a case where you expect some kind of data drift. However, whenever this is like unexpected, that's almost always bad. And this can come from like many different things, like data processing issues or like just bugs in the system. And the really kind of frustrating thing is also that this can be often very hard to catch by eye. So if you're just comparing, A versus B, they're both display activities. So it's not always very intuitive to the human eye to say which one is wrong, right? So yeah, we're using Arise a lot to help us catch these kinds of issues. So maybe as one example, this was a while ago, we were actually preparing to launch another A/B test with our ranking model, and everything like seemed pretty normal during our internal checks. We did a regular bug bash and so on. And then, after deploying the test, however, Arise kind of alerted us to a high drift in our model prediction scores. And again, this is not completely unexpected because we just deployed a new variation of the model. So naturally, you would expect some drift, some differences in how the models predict. But in this case, it was actually much higher than any previous A/B test, right? So this kind of then prompted us to kind of roll back this deployment. And then it was simply a matter of investigating and finding the bug. So in the end, it ended up being just a small bug in how the model training was set up. So then, thanks to that, we were able to quickly fix it and just redeploy the experiment.
Great. And Greg, how does this experience relate to other customers? Like, what would you say is the state of the art that most people use for identifying performance degradation?
It's a combination of a few things. I mean, for what we've seen our customers do in the past is that for what we have on platform for things like drift detection that Mihail's talking about is when, say, a production distribution differs from what's happened at a previous point in time, like in production or during your training portion of it. So we have a couple of things we look at, like PSI, KL divergence, and JS distance. I think, like, in the interest of time, I can talk a little about PSI, which is Population Stability Index. For what we're talking about is it allows us to go and measure and quantify what's happening now as opposed to what's happening at a previous point in time. So when there's a very significant deviation between that, like what Mihail is saying, sometimes a little bit is okay, but then when it's way off, that's the point when it's time to go and investigate what could have happened.
Got it. And Martin, from your side, are there any best practices or lessons that you've learned around monitoring the health and performance of the feature side?
Yeah, we have two sides. I can talk about the Tecton side, and then I guess Mihail can add a bit later about the Arise side. He knows this side way more better than me. Yeah, but from the Tecton side, we realized when we're going out quite quickly, we have these alerts on empty data, features and data being empty. But we also have a nice one which is called feature freshness, which is telling us, when was the last feature written to the online store? Because these are things that you assume are working, but you very rarely not see them. So we have these metrics actually coming through to us, and we can be alerted on them when they happen. An example of when this happened in the past, where it was really useful, is we have a lot of our data coming into the feature store from Kafka, so from stream processing. And anyone who works with Kafka, especially with a big company with multiple teams, nobody is consistent in sending the same data over and over again. Sometimes there's slight, tiny differences. And this can happen before. So we have an event that is sent from the mobile and from the desktop. And all of these were sending the same event, but there were slight differences in the data. And what was happening in this case was that the message was going to be processed, and then it was failing when we were getting this random feature that was this random Kafka event that was the data was totally different. I think something like this, if it wasn't for paying attention to the feature freshness, this would have been ignored and missed. We probably would have been caught with it with Arise a bit later, but with this feature freshness on Tecton side, we were able to catch it really, really quick. So I think even though Tecton is there for building, putting your features there in place, it also has some very useful, very, very useful metrics for you to monitor, such as the feature freshness. And then when it comes to Arise, I think Mihail can explain a little bit better on the practice got there.
Yeah, sure. So I would say, excuse me, like monitoring, I would say is like one of those like kind of like tricky things, because like, let's say having all the tools, monitors, and alerts is just kind of half of the equation. So what's actually really important is also establishing kind of a culture of excellence when it comes to model observability, and having actually model owners stay vigilant to alerts and actively follow up on them, right? So that's kind of very important as well. So what can be very helpful here is actually establishing SLOs around model observability, which is also what we've recently introduced in our team. So to give one example of such an SLO around model observability, so one of our SLOs actually assigns an upper threshold for how long, say, a data drift monitor can be triggered, right? So after a certain time of the monitor being in the triggered state, then we say the SLO is not met anymore. So this actually kind of yeah, having these kind of SLOs and practices in place really kind of incentivizes then the model owners to follow up on the monitor alerts and address the issue. So either by investigating, like, why is this monitor triggered? Is there something wrong with my model, or maybe the threshold is like just too low? So then adjusting the threshold. So I would say that's been a good practice to establish.
Okay. So far we were discussing monitoring on the side of when things go wrong. How do you catch them? But there's a good question about how do you measure the success? So Mike asks, how have you measured the success of discounted ranking impressions feature, and what have you seen in that respect?
Okay, yeah, I can also take this. So,
Yeah.
So whenever it comes to, let's say, choosing candidate models to potentially test, we can run all kinds of offline experiments like counterfaction analysis. So that helps us. But in the end, like, whenever success is measured online, so everything we pretty much do is tested via A/B test. So I would say, we have tested this. We are actually currently running an experiment on this feature. So fingers crossed that it turns out good. But I would say in general, everything is A/B tested.
So A/B test, so offline analysis and A/B testing is the way for measuring success.
Yes.
Got it. So do you do these tests at a per feature level or in aggregate at a model level?
So I think it depends a bit on, I think we do it per project level. So sometimes a project can have multiple features, so it's not just one feature, but maybe in, let's say, an embedding project that's more, involved. So then maybe you're testing one feature, which is an embedding. So it depends on the project. So we're definitely also testing them in batches, if you will.
Okay. Martin, so Mihail just mentioned embeddings. You've been utilizing more and more embeddings. Could you just elaborate on how embeddings help with your AI use cases and how you've been using them?
Yeah, so the most common use case with embeddings for us is tour similarity. So we have tens and hundreds of thousands of tours and different activities and variations of them. And with a lot of this, we can learn from past tours that are very, very similar. And so with a lot of these embeddings, we're able to do like similarity analysis. And this allows us to pull up data about similar tours. And this kind of comes back to this, this cold start technique too, which is what we're investigating now to help with this, is we can get a lot of very useful data from tours that are very, very similar from things like this. And we have this going now through, I think, I'm going to say 2 definitely, but there might be a few more where we're doing the same type of the same type of thing in place. And we're also looking now at hopefully bringing these onto Tecton, which should give us more up-to-date updates. At the moment, we're doing this, some of them weekly, some of them daily, but yeah.
Yeah. So when you talk about tour embeddings, what exactly is the input to these embedding models? So the output is a vector array, but what goes inside to, what's the input for creating that embedding?
Yeah. About all of them, I don't know, but the one that I know within our team, it's taking the tour description. So the tour description is something that's been created by the company or the person who's created a tour, and from this we can generally find quite good similarity, and we have like a similar length for a lot of our tour descriptions as well. So yeah, this works out quite well.
That's great. So yeah, I guess it's providing you a way for just incorporating unstructured data into the same models that you had before to just boost your recommendations.
Yeah, exactly.
Got it. There's another question on the chat here from Ashwini. Is there a separate model for non-personalized rankings and personalized rankings, or does the non-personalized model re-rank for user personalization?
Does the non-personalized model? So generally, I would say our approach is that we try to consolidate everything as much as we can. Just from a pure managing, let's say 15 different models, it's much harder than managing 1 or 2 models. So generally, I would say we try to keep everything contained as much as possible. So we do actually have just one model for both non-personalized and personalized ranking. Yeah, besides that, it's the two-layer ranking that I mentioned earlier. So we do have one more model that's kind of a batch model, but then as far as the real-time model that we use, then that's actually just one model in both cases.
Okay, cool. And then Tony asks a good question about training, which we didn't go in depth on in this conversation. So, what techniques and considerations are you using during model training? Is there anything special that you all do?
So I would say, yeah, this is a very good and pretty broad question. So I mean, techniques, I guess. So maybe one thing I can mention is that, like, as far as techniques go, or different like modeling approaches. So recently we've been experimenting a lot with like deep learning models specifically for ranking. So we're kind of moving away from more classical, let's say, ML approaches. So these models are like very much the state of the art. So there's a lot of exciting research out there, kind of backing their effectiveness in search relevance applications. And I mean, there's many reasons for that. One of them being the embedding features that we just discussed. Yeah, that's one of the techniques that we've used a lot recently. And considerations. So I think that's also a good one. So I would say one of the things to always keep in mind is the positional bias that you have in your implicit feedback. So this basically means if a user clicked on an activity, was it because it was truly relevant for them, or was it just because it happened to be displayed on like a very high position, say the first position? So that's something that's always kind of a challenge. We need to like keep that in mind. And the other thing is when it comes to like modeling bookings, there's not really any counterfactual analysis you can do on that. Like you can predict new rankings, but in the end, a booking that happened, it happened, right? There's no good way to like model what would have happened. Would the user have booked something else if you showed a different ranking? That's kind of very tricky to do. So yeah, I mean, just these are just two examples. There's many more considerations, I would say, but yeah.
Okay. And then, Greg, I would love to hear from you. You had mentioned before that there were these just newer type of LLM type workflows that people are dealing with, and maybe more deep learning models. So, what are the considerations that you're seeing on the observability side for those type of? Are there newer metrics? Are there newer workflows or techniques that people are using?
Yeah, for large language models, this is one that we are seeing really constantly with our customers. And the big question that we get from people, or one of them I'll say, is about, well, how do we know that the output of the LLM is correct? Like in the context of something like a RAG-based chatbot where you have a centralized source of information in a vector database, and customers are asking questions against that, and it returns an answer. Well, how do you know that that's correct? How do you know that it's actually telling the customer what you want and what is correct? So one way that we do that and that we incorporate in the platform with LLMs is what are known as evals, or evaluations. The other nickname we have for it is called LLMs as a judge. And what it means is that we use an LLM to evaluate the output of another LLM. One example of this is a hallucination eval, which means that we can take the original question that was asked, we can have the documents that were retrieved and the answer, and say, well, was this actually correct or not? From there, what you can get is a hallucination rate. And where that ties into, so say, our platform with that is you can measure that, you can monitor that, and say that if it gets above a certain point, then it's probably time to go investigate what is going on.
Great. Yeah, that's definitely a newer kind of workflow where even the metrics themselves are changing, and just the methods of evaluating models are just swiftly changing. So, Martin, question for you: you build this system and infrastructure that powers high scale millions of rankings per day at a very low latency. Just reflecting on your journey, are there any crucial lessons that you've learned, and what advice would you give to other ML teams out there who want to build similar systems?
I probably there's two big learnings I think we'd have. The first one is to plan what you can and can't handle as a team. This is really important because it will help you make the right decisions. The easiest thing at the beginning for us would have been to use a self-hosted feature store. But if we planned it and realized that as a team we can't really handle this. So I think that's the first thing: plan what you can't handle as a team, because this will help you as well. You'll make lots of mistakes going forward. We made lots of mistakes going through as well. And I think from start to finish, so this whole process we talked about before, from starting giving live inference models to having what we have now, we have observability and live features. This took roughly under 2 years, and a lot of this time was like not just building it, but also learning and going through the process of learning and building up standardizations. And then this comes to the second point. I think Michal mentioned it before as well, which is having best practices and standardizations within the company. So it's one thing having the products in place and the technology in place. The other thing is using it, especially with larger teams across multiple countries. I think having these standardizations in place, it's well worth putting these in practice as soon as things are coming through. You can't have everything perfect at the beginning, but after a couple of months, you will start to realize what are best practice and what works best for you as a team.
Yeah, makes a lot of sense. Another question from the audience. So Mike asks, are there particular segments of users that have responded disproportionately well to personalization, and how did you discover them? Mihail, probably a question for you.
So I think we're always, whenever, let's say, we're analyzing an online test, we're of course always like dissecting the data into different segments and seeing the performance. So that's like generally how we would look at it. I think personalization in general, I would say there's nothing. Typically, we've seen like if it's a user ID that we know has, let's say, booked before, or they kind of are more familiar with our platform, they tend to respond usually a bit better than like new users that are, a visitor ID that we've never seen before. But nothing like super disproportionate, I would say. It's been pretty equal across the board, I would say, more or less.
A question from Brett. How, if at all, does your model handle bias? Example, popularity bias of items. Do you account for this in your offline evaluations?
Yeah, that's a good question. So, that's one of those like really tricky things that is very, very challenging to really model. So we're not explicitly handling popularity bias. So the whole approach behind like the learning to rank framework is that you have your data, which kind of you accept as it is, and then you're trying to train a model that produces a better ranking. So whatever was clicked or booked by the user, you're always trying to put that at a better position. So there are potentially approaches to like tackle like for example, we've tested like positional bias that I think I mentioned earlier. Maybe like discounting our training data depending on like what position it was actually shown to the user in online. But that's been a bit like mixed success, I would say. So yeah, I think the bias is kind of there, and typically the approach is to kind of accept it for as much as you can.
Yeah, makes sense. Greg, is there anything you want to add here? Are there metrics that people use for identifying model bias, or for just evaluating offline models that do recommendations?
So even with things like if you're doing like offline evaluation, it's still one where I would come back to things like monitoring. Like one thing that we do have is, I believe was also in the article, is about evaluating on a delay. And that's also one thing you can also do, where you might want to take a look on a delay and be able to evaluate at certain points in time as opposed to others, and certain cadences with that as well.
Okay. Question from Shelby. How do you think about the right success metrics for online testing? Do you target down funnel metrics like bookings or revenue, which can take longer to move, or consider earlier signals to enable a shorter testing timeframe?
Yeah, maybe I can take that for ranking. And yeah, Martin, maybe you want to talk about growth as well. So for ranking, our main, let's say, primary success metric is always like revenue. So that is true that there's more variance and it can take longer to move. And that's why we have a more upper funnel metric for as a secondary metric or a guardrail. So if we see that generally like there's much less people viewing activities on like one side of the experiment that's like much higher, like upper in the funnel, so then that's kind of the guardrail that we would use to then decide to maybe stop the experiment early or not roll out the experiment in the end.
Yeah, and from our side, it's more or less a similar story. Yeah, from the input side for the growth team, a lot of it is based on net revenue of people coming in. This is kind of our upper part. But the interesting or the tricky one that you had was from the other side. So when we're giving recommendations for similar cross-sell items, so items that you might also like that are different to the item you just currently looked at. Here we had a lot of dillying and dallying going back and forth between metrics. So we started with bookings per visitor, revenue per visitor, these type of things. But they didn't kind of give us the feeling we had. And this we slowly learned over time. And we moved towards CR. These metrics are customer retention. I forget the name of what we call it. We have a lot of acronyms in the company. I think a lot of it as well is just over time. Over time, you learn what metrics work best for your model in particular situations. At least in this case, we didn't get it right the first time. It took us a while to get this correct metric.
Great. And then Shelby has another question. Which personalization features do you feel have contributed to the greatest uplift for offline testing? So we heard about the metrics that you're targeting, but what are the most important features that contribute to those metrics?
I would say maybe in general, any kind of the more explicit feedback from the user, the better. So you can think of, if a user has saved an item or viewed an item before, like these are very like direct, explicit user actions. So typically that's kind of a very strong signal. And then you have on the other end the impression discounting feature that I mentioned that is much less explicit, kind of more implicit. But there the idea is to then give a chance to like more different activities, even if the user hasn't interacted with it. So
yeah, and this kind of ties back to another question somebody in the chat asked a while ago, which is non-customers versus customer personalizations. So the ones that Mikhail's mentioned where they're very specific. These we have a lot less signals of these compared to the other ones. So the impression discounting, basically everybody gets impression counting. But then bookings and these very specialized, someone liked or clicked it, these a lot smaller. So even though they're more powerful, we can only target a smaller portion of our customers.
Got it. Okay. So we heard about your journey and all of your system components, which metrics you use, which features are important, and everything in between. But what are the next steps for GetYourGuide to improve the current setup flow? We heard about like embeddings is going to be more prominent, but what else are you thinking of building? And Martin and Mihail, both of you could chime in here.
Yeah, I can take a short go at it. So with our team, it's data scientists getting ready to set up and train. So I think as a company, we still haven't got this flow perfect. So from data science have the idea, exploring the data, and then starting to create the things in place. So Tecton have ways for us to do this within notebooks, for example, that we have. But we still need to put a process in place that is consistent and good for everybody within the company. So it's a very basic part of it, but it's still something that we need to really work on, I think, to make this whole process smoother.
And I would say for us in ranking in my team, I would say, yeah, our future plans definitely involve just fully embracing embeddings and supporting kind of more robust deep learning models that way. We definitely want to continue improving our personalization with these like real-time machine learning and real-time features. And yeah, just generally like continuing doing what we've already done and just improving our practices, our standards and practices around feature development and model observability, and making those as kind of efficient as effective as possible and accessible to everyone, and yeah, very low barrier to entry in general. That's our goal.
Yeah, makes sense. And then for Arise, Greg, are there things that you're particularly excited about, or that are coming up soon, or that were recently released?
Yeah, there's what I will say is that there are a number of features that are coming out at the end of June and July. So I could say to stay tuned on those. But one I can talk about is online evals are now live inside the application for LLMs. So what this means is that you're able to set up tasks you're going to be able to do that and automate actions on your data. And in this case, the first thing we've done is automating LLM evals. We just previously talked about LLMs as a judge. You're able to go and set those up in platform and run them. And you can also run them on not just all of your data, but you can run it on a sample of data of your choice. And this will just run against it. So we're really excited to go and release it. There's a lot of fast follows that are coming with that. And per earlier, that we have a lot of features coming out with ML and LLMs really, really soon in the coming weeks.
Great. Nice. Another question from the audience. Mike asks, how do you account for over-personalization, potentially disorienting users' expectations of where items appear in the list when they return?
It's a very good question. So I think in the end, as I mentioned, A/B test, the result of the A/B test is always what we go with. So if there is such a thing as over personalization and like users are kind of disoriented, then we would see that also in the performance of the experiment. So let's say conversion rates are down, click-through rates are down. So then that's kind of that's always like how we base our decisions. In the end, the result of the A/B test is what we look at the most.
Okay. And we've mentioned A/B testing a few times. So Martin, I'd want to know how does Tekton and your observability system fit in, if at all, for running these A/B tests?
Yeah, so the two of them kind of fit in quite nicely. I don't know whether by design or by look, but both of them fit in really quite nicely with our setup. So from the Arise side, I'll start from the back. We have tags that we can assign to the data. So these tags we can say from whether they came from the control model, from the control, or whether they came from one of the variations. And this way we can track, how the model and features are performing for specific parts of our A/B experiment. And from the Tekton side too, because Tekton has this concept of a feature service, if we really needed to. I think somebody asked a while ago about, do we test one feature or multiple features at a go? With having this feature service, you could have one for both the control and the variation. And here you have the flexibility to add just one feature for the variation, or you could add a whole bunch of features if you wanted. So I think the feature service that we have from Tekton and from the Arise side, the tags, both of these allow us to monitor and control A/B tests across the platforms.
Got it. Cool. So we have about 5 minutes left. So now is the best time to ask your questions in the chat. So one question that we have here from Jason is, how much data has been used in the training since the last 1 or 2 years? Is it last month, last week? And then the second part of that question is, does the training data include the year-round seasonal effects? So just if you could give a sense of the shape of your training data.
Mm-hmm. Yeah. So we account for seasonality in our features actually. So we have features that describe kind of seasonal effects for each and every single one of our activities that then we need to rank. And our training data, it depends. So I think I mentioned this pre-ranking model, which is our kind of baseline ranking batch model daily. that includes, I think, up to like 2 years of training data. So that's a lot. But then for a real time, it's much smaller. The scale is somewhere between a week or two. So there, we really try to capture the very latest patterns, and then kind of refine our re-ranking with that. And I say 1 to 2 weeks because that's something we also test with. So it kind of changes depending on like testing and so on.
Got it. And is that for across your all models, or is this for the specific this ranking model?
So this is just a ranking model. Of course, we have like many machine learning applications that are not ranking. So Martin mentioned cross-sell. We have other recommender systems as well, and there I'm not entirely sure, but it changes. So it is model dependent, very much so.
Cool. And then Tony asks, do you take into account similar users when determining how to rank items? That is, similar user likes this tour. Do you have like features for user similarity?
So we have features that describe the similarity between, let's say, user preferences and then the actual activity. But I think if you're talking more about the collaborative filtering style of recommending, we don't do that so much in ranking. We have other systems that use that kind of approach. So we do use it, but maybe not that much in ranking.
Got it. And then another question from Tommy is, do you have users landing on your website from marketing channels offering specific offers? And if so, does that impact what you show them on your site? So do you have features that look at the inbound type? That's how I would rephrase that question.
Mm-hmm. Yeah, we do have that. So a user can arrive to our platform through many different channels. So for example, via Google, or just naturally, organically to our website, or through a third-party website. So we have something like a widget in a travel blog, and then they can like arrive through that. So we do have this information, and we do utilize this also in many of our machine learning models, but also in ranking. So we've seen that different segments of users can have different preferences here.
Okay. And then probably the last question that we'll take from the audience. Shelby asks, you mentioned incorporating products viewed has contributed to the success of your ranking model, but what gives you confidence that the products a user viewed are ones they're actually interested in versus if they'd prefer to be exposed to other new products?
Yeah, that's another good question. I think my answer is going to be very similar to what I already said. So in the end, all of this is tested as an A/B test. So if depending how our users respond as measured by the test, that's always what's going to drive the decision to, let's say, roll out the new feature. But generally, I think there is always like biases present, and it's very difficult to kind of know, if the ranking was somehow, if we display this in different order, maybe the user would have clicked something else and booked something else. That's very tricky to know. So in the end, we just look at the data, which is the result of the A/B test, and that's what we use to decide.
Yeah, and in the past too, across multiple models, we've looked at kind of like diversity, like how to make the results that people are seeing more diverse. And these are very tricky to get right. I think every time we've tried it, the rules aren't like strong. These are very difficult to get right when you try to show things that maybe they wouldn't have seen this, but they might like it. These are the hardest sides to get right.
Great. Well, thanks a lot, Martin and Mihail. This was a great chatting with you and just learning about your systems. Thanks, Greg, for sharing all of the things that your customers are doing. We've written extensively on this topic in a blog post that we've shared in the link. So thanks everyone for tuning in. And if you have more questions or details, feel free to direct them to Tecton, and we can redirect them to anyone else. Thanks, everyone.
Thank you, and thank you for hosting this talk too.
Yeah.
Ciao.
Bye.
Bye.
Bye.